Forgive me, viewer, for I have sinned. I willed a 13-month-long Speedeebrite experiment into existence in defiance of the methodology and best practices of science. I created an experiment doomed to failure. This video is a direct result of that experiment. Viewer discretion is advised but not necessary. I'm Mr. Gigabytes, and let's find out what we learned from a 13-month-long Speedeebrite experiment. So, first of all, I'm going to have to apologize for the sort of clickbaity title for this video. It's inaccurate on two levels, and I'm going to circle around to that here toward the end of the video. But before we talk about the 13-month-long Speedeebrite experiment, we need to talk about the 24-month or 2-year-long Speedeebrite experiment, which started with the very first video. When I originally did Speedeebrite Experiment in approximately sometime in April 2019, I retrobrited a bunch of keys in different solutions, and toward the end of that video I stuck them on a keyboard just to see what would happen to them. These are the original ones that were retrobrited, these two here. They look exactly the same 2 weeks later. And I'm going to keep them on this board, and we'll just and I'm going to leave them out in the open. I'm not going to try and protect them or anything. And we'll just see if they remain and stay nice and white. Well, I still have that keyboard, and here it is. So over here we have the failures. This one was the bleach one. This one was the alcohol one, and this one was the vinegar one. And then we have these two keys, and then the strange water result that we got from that original experiment. But this one here was 3%, this one was 12%. And if you look, I don't know how well it comes out on the camera. So these keys look, at least in person, they look pretty much the same as they did 2 years ago. And that was kind of the whole point of this experiment. If we don't use UV light, we won't be damaging the plastic while we're trying to whiten it up. A lot of the people who use the UV light technique were complaining that after a few weeks the yellowing started to come back. Well, to me that seemed pretty obvious. You're using a massive amount of UV light, or even the sun, which produces a massive amount of UV light, to retrobrite your plastic. So you're doing damage to it at the same time you're retrobriting it. And so once the retrobrite effect wears off, you still have that underlying damaged plastic that it seems to be, in some cases it seems to be a chain reaction. The damaged plastic will just it'll just discoloring the plastic kind of on its own. The problem with this method is the heat. You have to put energy into the solution of some sort. UV light is one form of energy. It's radiant energy. It allows the solution to be very cool, so it can be used on a wide range of plastics. The issue is it's UV light. It's going to damage your plastic. This is good, but it only works on harder plastics, such as ABS plastic. If you use a softer plastic, and I did a video on that, I had a polystyrene bezel for a floppy drive reflow after putting it into the solution with the ABS plastic, and the ABS plastic came out just fine, but the polystyrene, the PS plastic, reflowed, and it warped and shrank and did all kinds of nifty things. So this particular method doesn't work well on those softer, more simple types of polymers. So we need to find another solution that doesn't use UV, that will also keep the solution relatively safe. And I have a few ideas on that. Videos forthcoming. But why I call it the 13-month experiment, it was actually closer to 16 months. But, 13 is a little spookier, but whatever. Rather than a 13-month experiment, this was intended as a 6-month experiment. So what was after I had done the very last retrobrite video, which is Adventures in Speedeebrite, Commodore 1541. What happened was I am a little lazy in cleaning up my mess. What was supposed to happen is I was supposed to revisit it in spring. So after we would have warm days and cold days and freezing days and sub-zero days, and then in the spring I'd come back and do another retrobrite experiment. The second video at the very beginning of this one, that was my attempt in the spring of 2020 to come back and revisit the retrobrite, see how much power it had lost. The issue was, suddenly there was COVID. Suddenly I was very busy. I'd got very few videos done that entire year. The solution sat around for quite a while, and I had a lot of false starts, and I shot a lot of a lot of B-roll, a lot of cold open, but of course it never made it to video because these particular videos take time to do. I finally was able to get it done in about February this year. That was about 16 months after that last Speedeebrite video. And what I did is I retrobrited this C2N case. I knew this was ABS plastic, so I knew it was going to take the heat. But I wanted to see if solution that had been sitting around for 16 months, it had been heated, it had been frozen, it had bugs in it. Like literally, before I could do this, I had to scoop out the detritus that had gathered into it. There was flecks of spray paint because I had painted in my garage. I had painted this PVC post gold, and it required several layers to make it look decent. So I spray painted this post gold, and there were flecks of gold paint inside the solution. So it had plenty of stuff to react to, and it sat in the dark, which is the most important thing. So it was not exposed to UV light. It was not exposed to a lot of heat. It was exposed to cold, but that slows down reactions as well. But it had been sitting for 16 months, and I expected it to fail. And it did. Sort of. So this mark here, this is where the cable was wrapped around this. So you can see where the cord was wrapped around here. Now, apart from it being slightly cleaner, there was some power in that Speedeebrite solution. The interesting thing is, in February, I had to do it in the evening. In the evening, it was in the garage. It was warm enough because it got up to 40 or 50 or something like that day. So when I did it in the evening, temperature dropped. It fell very rapidly. Like it went from 50 some degrees, which was fine to do it in the turkey roaster. It dropped to like 20 degrees in about 4 hours. And the solution never quite got to that. It got to about 165, 168. I didn't want to put a whole bunch of heat into it. So that was another X factor going against this experiment. But even still, I got it up to 165, 68 degrees, depending on where you measured the temperature of the water. And then when I did, I put just this bottom half into the solution and weighed it down, and then I turned the heat off. Now, on a regular normal spring or summer day, turning the heat off the temperature is going to drop very slowly and gradually. With as cold as it dropped to that night, the temperature dropped very rapidly. I'd say within an hour and a half, we were back to 70 degrees, pretty much. We're back to room temperature. And as we know from our experiment before, room temperature solution doesn't do anything. So this result is interesting because even though it's this isn't that yellow, and as the bottom is definitely cleaner than the top because we cleaned it, but it's very interesting just because just in this area in particular you can tell there was an effect. So how much of that 3% strength was left in that vat after 16 months? It's really hard to say because of the nature of this experiment. You can't deny that after an hour and a half in this solution, you definitely had a result. I didn't expect any result whatsoever. I expected it to fail completely. I expected all the hydrogen peroxide to have gone, to have completely disappeared. And I was going to come here and tell you, well, yeah, the experiment sucked and it was terrible and it was done wrong and all this. But the weird thing was, honestly, we did get some sort of result. We must have had some power in that hydrogen peroxide, and turning off the heat rather than maintaining it was a safer way to be. The third part of this experiment, because I turned the power off, I left it in the solution overnight. Well, by morning it was it was very cold. It wasn't ice, but it was, the solution was very cold. It was only 20 some degrees out. I pulled it out of the solution and wiped it off and cleaned it off. And like I said, we got some kind of result. So we're going to have to experiment a little more with this. Knowing what I know now, there is a multitude of different ways we can go with this. And we can see if we can get a result with a lower heat. Expect to see more Speedeebrite videos and some different techniques that you're going to be able to use without UV light. Stay tuned for an explainer video highlighting exactly how Speedeebrite and retrobrite work. That's all for now. As always, thank you for watching. It's rainy and overcast. Sounds like a perfect day to do retrobrite.